Okay, we'll start the problems on stagnation properties. Find the Mach number when an aeroplane is flying at 1100 km per hour through a still air having a pressure of 7 Newton per centimeter square and temperature of minus 5 degrees Celsius. Considered velocity is 0. Assume suitable data and find stagnation pressure, stagnation density and stagnation temperature. See here, this problem is based on stagnation properties. Therefore, from the problem we can write on the given data. Velocity is 1100 km per hour, that is 1100 into 1000 divided by 3600, that is velocity is 306 meter per second. Then pressure is given as 7 Newton per centimeter square, that is 7 into 10 raised to 4 Newton per meter square. Then temperature is minus 5 degrees Celsius, that is minus 5 degree plus 273 gives 268 Kelvin. Then gas constant R is equal to 287 joules per kg Kelvin. Then adiabatic index K is 1.4. See, if it is not given, then we need to assume it. Then first we need to find Mach number. Okay, Mach number, we know that Mach number is the ratio of V by C. Therefore, in order to find out the C, that is the velocity of sound or sonic sound, we know that formula C is equal to root of KRT. Substituting the values of KRT in this equation, we are going to get C is equal to 328.2 meter per second. Therefore, Mach number is equal to V by C, that is 306 divided by 328 gives M is equal to 0.931. Okay, this is the Mach number. Then we need to find stagnation pressure. See, stagnation pressure, there are two formulas for the stagnation pressure with respect to the Mach number and without considering the Mach number that we already discussed in the important formulas videos. Therefore, we know that stagnation pressure is equal to P naught divided by P, where P naught is what? Stagnation pressure is equal to 1 plus gamma minus 1 divided by 2 into M square, the whole raised to gamma divided by gamma minus 1. Therefore, P is 7 into 10 raised to 4, 1 plus gamma minus 1 is 1.4 minus 1 divided by 2. Then Mach number is already calculated, that is 0.931 square. Then gamma is 1.4 divided by 1.4 minus 1 is 0.4. See, on substitution we are going to get P naught as 12.24 Newton per meter square. Then similarly for the stagnation temperature, we know that T naught is equal to T into the bracket 1 plus gamma minus 1 divided by 2 into M square. On substitution, we are going to get T naught as 314.4 Kelvin. Then last one is stagnation density. We can use the stagnation density formula P naught is equal to rho naught or T naught, where P naught is the stagnation pressure, then R naught is the stagnation density, then T naught is stagnation temperature. Therefore, stagnation density is equal to stagnation pressure divided by R into stagnation temperature. On substitution, we are going to get stagnation density is equal to 1.355 kg per meter cube. See, in this problem, we can use the normal stagnation formulas also. We are going to get the same answer. You will see the next problem is air at 320 Kelvin, air at 320 kilopascal, 300 Kelvin, and Mach number is 0.6, flows through a duct. Determine the velocity and stagnation temperature, stagnation pressure and density. Okay, see, from the given problem we can write on the given data, that is pressure is 320 kilopascal, that is 320 into 10 raised to 3 pascal or Newton per meter square. Then temperature is 300 Kelvin. Then Mach number is 0.6. To find is velocity, stagnation temperature, stagnation pressure, stagnation density. Therefore, we know that the sonic velocity or velocity of sound is C is equal to root of KRT. On substitution, we are going to get C is equal to 347.8 meter per second. See, Mach number is already given. Then sonic velocity is calculated. We can calculate the velocity of the duct moving. Therefore, velocity when Mach number is equal to V by C, that is V is the velocity of the duct, then C is the sonic velocity or velocity of sound. Therefore, on substitution, we are going to get V is equal to 208.3 meter per second. Then to find the stagnation temperature, we can use T naught is equal to T plus V square divided by 2Cp. We can use the general formula T naught is equal to T into 1 plus gamma minus 1 divided by 2 into m square also we can use by considering the Mach number. Therefore, whichever is convenient we can use. T naught is equal to T plus V square divided by 2 into Cp. That is T is 300 plus 208 is a V square, then 2 into Cp, where Cp is a specific heated constant pressure. The value is 1.005 kilojoules per kg Kelvin. We need to convert that into joules per kg Kelvin because we are going to substitute the value of R in terms of joules per kg Kelvin for the sign conversion only. Therefore, that is 300 plus 208 square divided by 2 into 1.005 into 1000. On substitution, we are going to get T naught is equal to 321.9 Kelvin. Similarly, stagnation pressure P naught is equal to P into T naught by T gamma divided by gamma minus 1. Therefore, on substitution, we are going to get P naught is equal to 410 into 10 raised to 3 Newton per meter square. Similarly, the density rho naught is equal to P naught divided by R T naught. On substitution, we are going to get 4.437 kg per meter cube. The next problem is air is accelerated isentropically from 100 meter per second to 400 meter per second in a nozzle if the temperature at the initial state is 400 Kelvin and the Mach number at the final is 1.5. Determine the initial Mach number and final temperature. See, this is a very unique problem. Here the initial and final conditions are given. When the initial and final conditions are given, we need to use that already discussed in the given important formula video. We need to use that one.